Hi, friendly neighborhood mad scientist here again. This time, hyponitrous acid. Again, a name that I'm not going to hold you responsible for. So, hyponitrous acid. We in the honors course have talked about nitric acid, HNO3, nitrous acid, HNO2. This is below that, so it's HNO. Hyponitrous acid. What I want to do here is to use it as a chance to review our method for creating dot diagrams. So we're going to do this by the steps. Count dots. Make sure you report your count in your solution. Tell me, how many dots am I looking at, even if you don't show exactly how you count them out. We have to determine a central atom, more bonds. In our case, hydrogen makes one bond, oxygen makes two bonds, nitrogen makes three bonds, so nitrogen is going to be our central atom. Nitrogen is going to be our central atom, therefore oxygen is going to be considered an outer atom, as is hydrogen. But hydrogen gets what we call a duet. And I just want to make that a separate step to remind you that octets are not, but for everybody, hydrogen doesn't get one. Okay, then we add any leftover dots go on the central atom. Or multiple bonds from an external atom to the space between that external atom and the central atom. We're going to be shifting electrons if we need to. And we want to check our octet and duet rules to see if everybody has the right number of dots. 6 rules. The hardest of those is the last one. That multiple bond thing always feels a little weird the first couple of times we apply it, and then it starts to make sense. Yeah, that worked. All right. So those are our rules. Now I can certainly send you those. Whoops. My rules didn't come across perfectly. Okay. But now let's apply those rules. And to apply those rules, we said that we were going to count first, and let's do that. I have 6 dots for oxygen. I don't have 10 oxygens, I just have 1, and so that's why I put the little quote marks there, that I want 6 dots. I want 5 more dots because this is nitrogen. But I'm going to end up with a total of 12 dots because I get 1 dot from hydrogen. And there's my 12 dots. So HN, oh, notice that I'm writing these in exactly the order that they were given in the original problem. That's very commonly done. In chemistry, we're not trying to confuse you. So pay attention to the order in which things are offered you, and maybe write them down in that order when you go to solve the problem. It usually works that way. Okay, so let's apply our rules now, where we are going to be adding our dots for oxygen. 2, 3, 4, 5, 6. I'm going to steal a couple from nitrogen, and I'm going to complete the octet on my oxygen atom. Okay. Now I want to add those dots from hydrogen. Hydrogen brings up 1. We're going to steal another from nitrogen. And so we see the 1 dot from hydrogen. We see the 6 dots from oxygen. Oh, but I only have 3 dots coming from nitrogen. I need to have 5 dots. Now I have a total of 2, 4, 6, 8, 10. There are 12 dots. Everybody's so happy right now. Woohoo, yay. But let's double check. Does hydrogen need an octet? Of course, the answer is no. It needs a duet, and we're done. Does oxygen need an octet? The answer is yes. We have that octet. Done. Does nitrogen need an octet? The answer is, of course, yes. You need an octet nitrogen. What are we going to do? Well, oxygen has usually got 2 bonds associated with it. Right now it only has 1. Nitrogen definitely needs another set of electrons. So we're going to take these electrons. Let's take these electrons. I got them out. Come on, I want those electrons. And I want to move them. I'm going to move them over here first. Nope, bad idea. Why is that a bad idea? Well, nitrogen now has its octet complete, but oxygen is now left with 6 electrons. I don't like that. What am I going to do? I'm going to take these electrons. Oh, look, I've tilted them. I don't want them to stay there. I want those electrons to come with me right over here. And now, look at what we have. We have an octet on nitrogen. We have an octet on oxygen, but only if 4 electrons are considered to be part of both atoms at the same time. That's the definition of a covalent bond. 4 electrons shared between 2 nuclei is the definition of a double bond. And what we would then sketch in 3 dimensions, which I will just do in black just to make my life a little easier here. I'm going to put my hydrogen, nitrogen, and oxygen all in the same plane. They're not on a straight line because there's a lone pair here on this nitrogen atom. And yes, I'd like to incorporate that lone pair. Here's my 120-degree angle because trigonal planar around nitrogen. And lastly, my lone pairs on my external atom. They have no impact on the shape of this molecule, but they are there for artistic completion. Done. Hyponitrous acid, HNO.